Hi guys, I'm going to solve the perfect Bayesian equilibrium of this signaling game, but there's a story of this game, and so we are asked to draw this game tree. So let me read the question first, okay? Here's the question. There's a company, and the company introduces a new product. The product is either good or bad. The prior probability that it is good is going to be 0.6. The company chooses whether or not to advertise the product, where advertisement costs $C and no advertisement costs nothing, $0. Payoff of representative consumer from buying the product is 1 if it is a good product and -1 if it is a bad product, and consumer's payoff is 0 if she does not buy the product. Well, if the product is good and the representative consumer buys the product, well, then the company sells the product to other customers or consumers, enjoying therefore a high revenue of denoted capital R. If the product is bad, however, and the representative consumer buys it, well, then the company will have only a small revenue denoted by small r. If the representative consumer does not buy it, the product, then the revenue of the company will be simply 0. So assume that R, C, R, and capital R are all positive, and capital R is greater than C, and C is greater than small r. Okay? All right, so the game tree is going to look like this. Well, the starting point is this center point where we put the nature as the initial player. Well, here it is actually the quality of the product will be determined by the company, obviously, but we are not asked, whether the firm prefers to produce high quality or low quality isn't the choice that we're going to be focusing. So for that reason, we assume that the nature, without loss of generality, nature determines the type of the product. And then we're going to be focusing on the firm's actions, whether the firm is going to advertise or not advertise. All right. So for that reason, the nature is not really a player, determines the quality of the good. Well, the product is going to be good with probability 0.6, therefore it's going to be bad with probability 0.4. Okay. Well, whether good or bad, the product, the firm is going to either advertise or not advertise. All right. Well, so therefore here I have a good product firm, or so this is the firm, basically firm with a good product, and this is the firm with a bad product. And firm either advertises or not, okay? Well then, observing the advertisement or no advertisement, the consumer decides to buy the product or not buy the product. All right, so the consumer, so this is the info set of the consumer, but we have two different info sets. The consumer can observe whether the firm advertised or not, right? You can just watch the TV and see the advertisement, so you observe that. But the thing, well, why do I have a two information set? Well, the thing is the consumer cannot observe whether this advertisement is coming from a good product or coming from a bad product, or is this advertisement about a good product or bad product? That is an incomplete information for the consumer. All right. Obviously, firm knows its product. All right, but the consumer doesn't. So for that reason, we have two information sets for the consumer, and in each information set, whether he observes advertisement or no advertisement, so NA refers to no advertisement, the consumer is going to choose between buy or not buy. So simple decision. All right. So if the consumer buys the product and the product is good, all right, well then whether there's an advertisement or not doesn't matter. The consumer is going to get 1 payoff if he buys, if she buys, and 0 if she doesn't buy. Well, then the consumer is going to get -1 payoff if the product is bad, and 0, always 0 if she doesn't buy it. All right, so whenever you have DB, don't buy it, the consumer's payoff, which is the second payoff, should be 0. And whenever she buys the product, well, then the payoff is +1 or -1, depending on the quality of the good, all right, or the product. All right, well, what about the firm's product? Well, the firm's product depends on two things. One, whether the product is good or bad, and two, whether the firm advertises or not. So if the product is good and the firm advertises, so advertisement always has a cost minus C, all right? Whether you sell it or not, whenever you advertise, you're going to spend minus C dollars as a firm. Well, however, if your product is good and the consumer decides to buy it, you're going to get big revenue, capital R, all right? However, if the product is bad, you're not going to be able to sell too much because at some point other customers will realize that the product is bad. I think that's the intuition. And so you're going to get only small r as a revenue. So obviously if the consumer, so this is a representative consumer. So think of this as like average customer. So if the average customer doesn't buy it, obviously you're not going to get any revenue, only the cost of advertisement. On this side, because there's no advertisement, there's not going to be any C. So basically, the same things, whether the customer buys or not. If the customer doesn't buy it, always zero. There's no C because there's no advertisement. And if the customer decides to buy it, well, it's going to be a big revenue or small revenue depending on the quality of the good. All right, so that's the game structure or game tree. And so this is the assumption for the parameters, and the question was find all perfect Bayesian equilibrium of this game. All right, so now I'm going to first work on the separating equilibrium of this game, and then in the next episode I'm going to solve the pooling equilibrium of this game. All right? Okay, so let's solve the separating equilibrium of this game. And remember, a perfect Bayesian equilibrium are usually have two sorts, separating in pure strategies, separating equilibrium, all right, and then the pooling equilibrium. Well, what's the idea of separating equilibrium? In the separating equilibrium, the idea is that each different type chooses different actions. So therefore, the second player, here it's the customer, by looking at which action the first player has taken, can actually distinguish the types of the first player, okay? In a separating equilibrium. In the pooling equilibrium, as the name suggests, all types choose exactly the same action. So therefore, the second mover, customer, cannot distinguish between the types by only observing the action. All right, so that's the idea. Obviously, there are different equilibria as well, the hybrid equilibria. But in a game like this, where we have two players and only two actions for each player, well, then we cannot have a hybrid equilibrium if we are not looking at mixed strategy Nash equilibrium. Again, we're only focusing on pure strategy Nash equilibria. So therefore, the perfect Bayesian equilibrium has to be one of these two. I'm going to look at the separating equilibrium first. But always, the good idea is to understand what the players are, what their types are, and their strategies are, okay? So always do that exercise before starting solving the game. So who are the players in this game? Well, there are two players. Nature is never a player. Well, the first player is the firm, right? And then the second firm is the representative customer. Okay, well, how many types firm has? Well, the firm has two types. The firm with good quality product and the firm with bad quality product. The firm can observe its the quality of its product. So therefore, these are the types. All right, so these are the types of the firm. The consumer doesn't have a type. Consumer is just one type in that sense. And the customer cannot observe the type of the firm, whether the product is good or bad, or whether this is the firm with a good product or firm with a bad product. And therefore, this 0.6.4 represents customers' uncertainty, okay? There is no uncertainty for the firm. The firm knows everything. The customer is unsure about which opponent he's facing, or she is facing. Okay, well, what about strategies? Well, for the customers, the strategies are either buy it or don't buy it. That's it, right? I mean, I'm sorry, not the strategies, the actions are either buy it or not buy it. Well, what about the Firm. Well, whether it's a good firm or bad firm, or I'm using by slightly abusing the lingo, is like whenever I say good firm, I mean the firm with a good product, okay? So the good firm or bad firm doesn't matter. The set of actions are either advertise or not advertise. These are actions, okay? Well, now let's be more specific. What about the strategies? Okay, so here you have to be careful. Remember, strategy is always a function which maps each information set of a player to an action. So here, each type should have a strategy. Well, the good firm has a strategy. So good firm, or again, firm with a good product. Bad firm, or we can just ignore the firm, so good, bad, and then the customer. So these are, in a sense, there are two players. Remember, in a Bayesian game, we not only consider the players, but also each type of each player. So therefore, we have, in a sense, three quote-unquote players. The customer, an actual player, firm, but two types of the firm. So in a sense, we have three players. Well, the good firm has, remember, two actions. Advertise, not advertise. Okay, bad firm has two actions. Advertise, not advertise. And then the customer. The customer has, yes, two actions. But the thing is, customer has two information sets. The one on the left, meaning whenever the firm doesn't advertise, and the one on the right, whenever the firm does advertise. So therefore, strategy for a customer, therefore, has to be tuple. Action here and action there. So a customer's strategies are going to be like BB, meaning buy regardless of the advertisement. DB, meaning never buy, and then BDB, meaning buy only if you don't observe advertisement, and buy only if you don't observe advertisement, and don't buy whenever you observe advertisement, and just the opposite, don't buy, buy. Okay, so let's write them as this. So these are the strategies of the customer. And these are the strategies of the good and bad type of the firm. Again, they're not tuples because each firm, whether good or bad, has only one decision node. Remember, the nature is not a player, so we don't really care about its strategies. So these are the strategies for each player in this game. Hence, if we're talking about a perfect Bayesian equilibrium, we're going to have a vector, something like this, A, B, B, for example. Meaning, the good firm, so always follow this order, the good firm will advertise, the bad firm will advertise, the customer will always buy. So this is one possible strategy profile. Another possible strategy, so all combinations of these strategies. A, not A, buy, don't buy. All right? So what does that mean? That means the good firm is going to advertise, bad firm will not advertise, and the customer is going to buy whenever it observes no advertisement and doesn't buy whenever she observes advertisement. All right? So there are a bunch of different potential strategies. But in a perfect Bayesian equilibrium, remember, we also care about a belief structure. So here, the belief structure, this is the requirement 1, if you remember. So we're going to assign probability P here, 1 minus P here, and probability Q here, and 1 minus Q here. They represent the customer's beliefs about whether the firm is a good type or bad type, all right, in each info set. So therefore, whenever we talk about a perfect Bayesian equilibrium, we're going to talk about a vector of strategies and also P and Q. I mean, some specific value for P and Q. So that's going to form perfect Bayesian equilibrium. All right. Well, the separating equilibria, well, by definition, the separating equilibria or equilibrium means two different types takes different actions. So this, yet I don't know if it is an equilibrium or not, but it cannot be separating equilibrium because the types of the firm are actually taking the same action. All right. So therefore, if we're talking about separating equilibrium, we can only have two separating equilibria, right? One in which A and A, and the other one is NAA, which basically means the good firm. So let's refer to the first as the good guy, and this is always the bad guy, all right? And so the good firm advertises, the bad firm doesn't. So that's one potential separating equilibrium. Another separating equilibrium, potentially, I mean, we haven't yet proved that they are separating, is this time the good firm does not advertise, the bad firm does advertise. All right, that's it. I mean, in this game, we cannot have any other separating equilibrium. I mean, if you look at all the combinations of these, all right, I mean, here we have two strategies for good firm, two strategies for bad firm. So therefore, there's going to be 2 to the power 2, 4 combinations, AA, ANA, NAA, and NANA. So therefore, out of these 4, only 2 of them are potentially separating equilibrium. Well, what about the pooling equilibrium? Well, they're going to look something like this. I mean, which one? I don't know yet. Maybe none of them are equilibrium, but a pooling equilibria is going to look like both firms advertise or both firms don't advertise. Okay? So, remember, in this episode, we're focusing on separating equilibria. So I'm going to look at these two. The question is, what should be the other strategies? I mean, the consumer's strategies and P and Q. And obviously, we have to satisfy requirement 1, remember the existence of this PQ, and then requirements 2, 3, and 4. So this is what we're going to check now. Okay, so I start with this separating strategy. The good firm advertises, bad firm does not advertise. Can this be part of any perfect Bayesian equilibrium? Well, always put the arrows. So the good firm advertises, all right, and the bad firm does not advertise. Okay, so that's it. Well, what does that mean? So given this strategy, question is, does the second player, I mean the consumer, chooses optimally? Well, the question is, what is his optimal choice, optimal strategy, given these strategies of the first player, I mean the firm? Well, it's easy to find and calculate. How so? Well, the good firm is going to play A, meaning it's going to advertise, and the bad firm will not advertise. That's the strategy. Remember, we're checking basically a Nash equilibrium. We fix one player's strategy and then try to see if the other guy is best responding this. So we fix this strategy and treat as if the consumer knows this strategy. So if the consumer knows this strategy, that means whenever consumer observes advertisement, it should be coming from the good firm, not from the bad firm, because the bad firm is supposed to not advertise. All right? So remember, we fixed the firm's strategies and now trying to find the optimal strategies for the consumer. Okay. So therefore, whenever the consumer observes advertisement, he's going to say, okay, this must be the good firm. Hence, P must be 1 by Bayes' rule, okay? Well, what about Q? Well, then Q must be 0 because whenever you don't observe advertisement, NA, I mean, you're going to say it must be the bad firm. So this probability should be 0. This probability should be 1, therefore. So the question is then, the consumer will know that she is at this decision node. So she's going to ignore this part of the game. And so the question is, which strategy is optimal for her at that decision node? Well, if she buys the product, she's going to get 1. If she doesn't buy the product, she's going to get 0. So therefore, you know what? She should buy the product here. I don't care what's happening here because, as I said, she believes under those strategies of the firm, she is actually playing here. All right, so for that reason, we ignore those payoffs. And here, whenever the customer observes or the consumer observes the not advertisement, she's going to believe that she's at this decision node, and her optimal strategy is not buy because 0 is higher than -1. Okay? So therefore, given that A and NA are the strategies of the good and the bad firm, well, then the optimal best response for the consumer is to not buy here and then buy here. All right. Well, I mean, whether you put comma here or not, I mean, it's totally up to you. So therefore, now given this, the consumer is best responding. Well, so we are halfway through requirement 2. There's one more thing that we should check to complete requirement 2. Well, because there's another player, I mean the firm. We never checked if the firm is best responding, right? So now we should check if the firm, remember we said firm is playing, I mean the company is producing, advertising or not advertising, but the question is it really a best response? To what? To this strategy. That's the thing, right? Because we calculated that this is the best response to this. Question is this a best response to DBB? All right, so for that reason, remember here the consumer is buying, so also put arrow to the B. Why is that? The consumer cannot distinguish these two decision nodes, and so she's going to buy whenever she sees an advertisement. This is what DB here, B here means. And DB in both of here. Okay. So the question is A really a best response for good firm? And then is NA best response for bad firm? Well, let's look at the good firm. If the good firm takes the action A, his payoff is going to be R minus C. So let's write that. If you take A, the payoff is going to be R minus C because according to those strategies, again, we're fixing one guy's strategy and checking if the other guy is best responding that strategy as if he knows what his opponent is going to play. Again, this is all just Nash. Don't forget that. So if he plays A, he knows customer or consumer is going to buy, and so he's going to get R minus C. However, if he plays NA, he knows that the customer will not buy it, and so its payoff is going to be 0. So this is the good firm's payoff. Well, which one is higher? Well, R is greater than C, so R minus C is positive. So you know what? Given that these are the strategies of the consumer, the good firm will actually advertise. All right, so A is a best response to DBB. Good. Well, what about the bad firm? A is a best response for good firm. All right. Well, what about the bad firm? We're done with this. So the good firm is in fact best responding. What about the bad firm? Well, the bad firm, if it doesn't advertise, it knows that the customer will not buy it and hence its payoff will be 0. But what if it decides to advertise? Well, if it advertises, all right, you may say, if the bad firm advertises, we said the customer will distinguish it. No. Don't forget, the customer can only observe advertisement or no advertisement. All right? And so here, the customer believes that the bad firm will not advertise, but the good firm will. So let's suppose the bad firm deviates and also advertises. So the customer will just see the advertisement, doesn't know whether it's coming from the bad firm, good firm. It just believes that it's coming from a good firm. And so therefore, the customer will still play buy here. All right? So by manipulating, by deviating to another action, you can actually mimic the good firm. All right, so the bad firm can mimic the good firm and sell its product as if it is a good quality product. All right, so that's the idea. The question is this deviation profitable? It shouldn't be if this is an equilibrium. All right, well, let's check. If instead the bad firm deviates to A, the firm knows that the customer is buying, and so its payoff is going to be R minus C. Remember, I mean, you're advertising, so you're going to have a cost. But the thing is, because your product is not high quality, you're not going to get capital R, but small r. Well, the thing is, R is less than C, so this guy is negative. So you know what? Not advertising is in fact a best response. So NA is a best response for bad firm to this strategy, don't buy. So, conclusion, both good firm, I mean the firm with a good product and the firm with a bad product, they both best response the consumers' strategies. Strategies of the consumers are best response to the firm's strategies. In fact, the strategies of the consumers are best response to the consumers' beliefs. And so everybody is basically best responding each other. And hence, those strategies, those I mean A, NA, DB, B. So these are satisfying property 2. So don't forget, this is the good firm, this is the bad firm, and this is whenever you see no advertisement, and this is whenever the customer sees advertisement, okay? And then the P equals 1, Q equals 0. So it satisfies requirement 1 by just throwing PQ there. It satisfies requirement 2. What about requirement 3 and 4? Well, there is no requirement 4 here because there is no off equilibrium information set. So ignore requirement 4. Only requirement 3. And the requirement 3 is, remember, whenever the information set is on the equilibrium path, the beliefs must be updated according to Bayes' rule. And we initially already calculated these updated beliefs. P must be 1, Q must be 0. So you know what? This strategy profile and the belief structure satisfy requirements 1, 2, 3, and 4. And hence, this is a separating perfect Bayesian equilibrium. That's it. Okay, so now it's the second potential separating. This is a second separating strategy profile, and we're going to check if it is also PBE. All right, the good firm does not advertise. The bad firm does advertise. Can this be a part of perfect Bayesian equilibrium? All right. Again, the first question. Given those strategies of the firm, what should be the beliefs, P's and Q's? And then given these P's and Q's, what should be the best response or the optimal strategies for the consumer? And then given the consumer's strategies, are these really best response? And so basically that's it. That's all we have to do. So given those strategies, what should be the value of P and Q? Well, remember, if the consumer observes an advertisement, it's going to believe, because the consumer believes that these are the strategies of the firm, she's going to believe that the advertisement is actually coming from the bad firm. So it means she is at this decision node, which basically means P must be 0 and Q must be therefore 1. Okay, that's it. Well, given that P is 0, I mean, this is the information set a consumer is whenever she observes advertisement. What's the optimal strategy? Is it don't buy or buy? Well, if she buys, it's going to be -1. If she doesn't buy, it's going to be 0. So clearly she's not going to buy. And here, she believes that she's at this decision node with probability 1. And so if she buys, she's going to get 1 payoff. If she doesn't buy, she's going to get 0 payoff. So therefore, she is going to buy. So given those strategies, these are the beliefs according to Bayes' updating. And then given those beliefs, the optimal strategies for the consumer is buy here. I mean, buy whenever you don't see advertisement, and don't buy here. Okay, one last thing. Given those strategies, is those, good firm and the bad firm, are they best responding? Okay, don't forget, the consumer will buy whenever she's in this info set. Okay, so put the arrows here, and whenever she's in this info set, because she cannot distinguish these two decision nodes. So therefore put arrows here as well. I mean, she cannot say, I'm going to buy it here and not buy it here. I mean, she can't do that because she doesn't know exactly which info set she is. She only believes that she is in this decision node. This is what she believes. All right, well, given those beliefs, do you think that the firms are actually going to be honestly play those strategies, or are they going to deviate? Well, the good firm, if the firm does not deviate, so this is the good firm, if it does not deviate, it plays non-advertisement, its payoff is going to be R. Okay, but if it does deviate and advertise, its payoff is going to be minus C, because firm knows that the consumer will not buy it because she believes that the advertisement coming from the bad firm. All right, so doesn't advertise is going to give the firm minus C. So you know what? NA is a best response for a good firm to which strategy? BDB. Okay, good. So therefore, the good firm is best responding. What about the bad firm? Well, the bad firm, it's advertising, and in this case, we know that its payoff is minus C, because the firm cannot sell it, but has to pay the cost of advertisement, so it's minus C. Well, if it does not advertise, however, if it mimics the good quality firm, well, the consumer is actually going to believe that the no advertisement coming from the good firm, and so it's going to buy the product, and so the firm is going to make small r profit. R is higher than minus C, so therefore, you know what? A is not. Remember, the bad firm's strategy was A, and A is not a best response to BDB. So what does that mean? That means those strategies, strategy profile, NAA, and then BDB, and then P equals 0, Q equals 1, is not perfect Bayesian equilibrium. Why is that? Well, it does satisfy requirement 1, requirement 3, requirement 4 by default, because there's no off equilibrium info set, but it fails to satisfy requirement 2 for who? For bad firm. Bad firm actually prefers not to advertise, given those strategies. So therefore, this cannot form a perfect Bayesian equilibrium. All right? So the conclusion in this game, there is only one separating perfect Bayesian equilibrium, and in that equilibrium, we just mentioned, good firm will advertise, bad firm will not advertise, and whenever the consumer observes advertisement, she's going to buy it, and whenever she observes no advertisement, she's not going to buy it. So that's the only perfect Bayesian equilibrium, separating perfect Bayesian equilibrium. Next episode, I'm going to talk about pooling equilibria, okay?